Hi guys, in this video we'll be talking about how to add two fractions that do not have the same denominator. Okay, so this is where we get into the good stuff here. Just like we did before, just a review, when we did it with middle school math, we said first, what's the smallest thing that 3 and 5 both go into? They both go into 15. Then we had to make an adjustment to the 2 and the 4 because it's no longer 2/15 and 4/15. We had to multiply by whatever it took to get up to the common denominator. So 3, I had to multiply by 5, so I multiplied the 2 by 5, right? So that's what we're going to do here, okay? We're going to get a common denominator first, and then we're going to combine the fractions, and then we're going to look to see if it reduces at all. So the first step to getting the common denominator is just factoring, okay? What do I have over here? I have a 9 times an x, right? 9x squared. On the right-hand side, it looks like I can pull out a 3x. And if I do that, I'm left with x plus 1. Why is that important? Because when I take these two and I want to combine them, I want to say, okay, what's the smallest thing that 9x squared and 3x squared plus 3x go into? It's easier to see from this format that they'll both go into numbers-wise a 9. 9 is the smallest number. The x, I have an x here, but I actually have a pair of them here. So x squared, I need to have at least an x squared. And then I need this x plus 1 term, right? Now everything is represented. Will 9x squared go into this? Sure it will, because 9x squared is right there. I just have to multiply, it looks like the left fraction, both top and bottom, by x plus 1. Will 3x times x plus 1 go into this? 3x will go into 9x squared for certain, right? But I need to multiply by 3, both top and bottom. And it looks like I need another power of x to get up to x squared. And it looks like the x plus 1 is taken care of, right? So to get from 3x squared, 3x times x plus 1, to 9x squared times x plus 1, it looks like I need to multiply by 3 and by another x. And you can kind of see where we're going with this then, right? So it looks like then I'm going to make some adjustments. It's going to be over 9x squared times x plus 1 both times. What do I multiply? It's no longer 7 and x, right? It looks like I need to multiply the left side by the x plus 1. So I have 7 times x plus 1. That's distributive property. On the right-hand side, I have x times 3x. So combining those together, now that they have the same denominator, I can write them as one fraction, right? Similar to how, once I got them in the same denominator over here, I said, how many 15ths do I have? This time, it's how many of these things do I have? The left-hand side, 7x plus 7 is the first fraction, right, when I distribute out the 7. And the right one is x times 3x, which is 3x squared. And so we have a number of different ways we can leave our answer. I would like you to leave it in the correct format. Or standard format is start with the highest power of x, so 3x squared, plus 7x, plus 7, and it's all over 9x squared times x plus 1. And there you go. That's it. That's the reduced form of the fraction. You can leave it just like that if you want to. Let's do one more problem, and then I'll be done with this video. This problem is going to be subtracting, okay? And so the only catch here is paying attention to the negative signs. If I go through and I factor out the bottom here, what is the smallest thing that 2x minus 2 and x squared minus 4x plus 3 go into? The left side factors out to 2 times x minus 1. The right fraction, two numbers that multiply to positive 3 add up to negative 4. I'm thinking negative 3, negative 1. In order to have a common denominator, it looks like the smallest thing number-wise they go into is a 2. I have an x minus 1 in both of them, so I need to make sure to include that. And then I have the x minus 3. And I can go, okay, will this go into that? Will 2 go into this? Yes. Will x minus 1 go into that? Certainly. It looks like I need to multiply the left fraction by the x minus 3 though, right? So I've got some FOIL that's going to happen here. The right fraction minus will x minus 3 go into this? Certainly will. Will x minus 1 go into it? Certainly will. Looks like I need the 2 in order to get up to the common denominator in the right fraction, right? So now it's time to kind of rewrite all this. The left fraction becomes x minus 3 x plus 2. That is a minus. The right fraction becomes a negative 2x minus 1 and a 2. Be careful with the negative signs here. Here we go. These are all going to go over 2 times x minus 1 times x minus 3. This here becomes x squared minus x minus 6 when you FOIL it out. If you don't believe me, go FOIL it out on the side. Two numbers, they add up to negative 1 and they multiply to negative 6. Now the tricky part. I am subtracting everything here. I am subtracting this entire piece. So if I take care of just this first, if I just look at this and I say if I distribute the 2 out, that gives me negative 4x minus 2. Well, guess what? You are not only subtracting the negative 4x, you are subtracting the negative 2. In other words, I need to write it like this because I see that the negative sign now distributes to both the negative 4x and the negative 2. That flips both of their signs. That means that I'm going to end up with x squared minus x minus 6. But then it becomes plus 4x, and the one that's always missed is the plus 2. That's over this. Now I just need to combine like terms. I only have a single x squared, so let's just use that. As far as x's go, I have 4x minus x, which is plus 3x. And as far as the last terms go, I have plus 2 minus 6, which is minus 4. That is all over 2 times x minus 1 times x minus 3. Oh my gosh. Guess what? We're not done yet. I did not expect to give you one that looked like this. Okay? We do need to take a second and look and make sure that this doesn't reduce at all. Okay? And it turns out that this one does. We're not quite done yet. We got one last step. The last step is this. See that top? Think Mad Minute. Does that factor? Two numbers that add to 3 multiply to negative 4. How about positive 4 and negative 1? So that's the same thing as this, right? So I'm going to put a line through this for just a second. And now when I do that, look what happens. This goes away. That goes away. And I'm actually left with a reduced answer of x plus 4. We have to reduce our fraction in the end. The bottom has the 2, and it has the x minus 3. So like I said, you would think that multiplying and dividing would be the easy problems. It turns out these are the ones that kind of suck, to be honest. Those are long problems, right? But don't get overwhelmed, okay? There's what we did. Number 1, we found a common denominator. Step 2, we adjusted our numerators by multiplying by something. Step 3, we combined like terms. And then in this case, we had to factor the top, and it turns out that it does factor. Not all of them will. And when we factored it, some of the stuff canceled out, so we reduced our fraction. Nothing different than working with numbers, just a lot more stuff to write down.